Hello everyone, you are welcome to this class. So in this class, we want to look at angles. So under angles, we have this set of objectives that we want to achieve. So the first one is we want to look at lines and its types. Then we'll move to angles, what the meaning of angles. Then we're also going to look at angles between hour and the minutes hands of the clock, right? The last part will then be the relationship we have between degrees, minutes, and what seconds. So the first one is line. So let's look at types of line. Under it, we look at some other things there. We have about 9 points that we want to look at there. The first one, types of line. Types of lines. Because understanding of this concept, these angles, what we're going to look at in this video, will make you to understand the subsequent videos we're going to be looking at. Because we're going to be looking at some theorems that are attached to angles. So understanding of these basic things will help you a lot. That is the reason why you need to pay attention. Very, very serious in this video. So the first one is point. Point. When we talk about point, point is used to show position of an object in the space. For example, I can have point A here. So that I'm showing the position of A. If I have a grid, what do I mean by grid? This I have a grid like this. I have a grid like this. Alright, just like graph. So if I put a point here and name it A. So I'm showing the position of this object A. So I can say, okay, a boy is at this point. There's a boy. And we have another point here showing a girl. And we have another point here showing a man. You understand? So all these points here are what? Used, or they are indicating the position of all these objects, of all these people in a space. Exactly. So that is what point is all about. Then we move to line. So that point is used to what? To denote the position of an object in a space. Then the next one is line. So on that line is because understanding of points will let you understand line. So line is set of points. When you have set of points, it's formed line. For example, I can have point here, point here, point here, point here, point here, point here. So so you can see there are spaces between these points. I can fill up the spaces with what? With points. So this will form a line. So that is the reason why we want to define a line. We said a line is a set of what? Points that form this line. So set of points forms a line. So if you have any line, this is a line. So it's set of points. Points. By the time you by the time you move to higher level, you understand it. If you have a circle, if I draw a circle now, this circle is a set of points that form this line. Are you with me? So that is what we refer to as line. So under this line now, we're going to be looking at different types of line that we have. So we are going to have the first one. We have a straight line. Straight line. Straight line. Straight line is very simple. So when a line is straight, that is not bent. So it's straight. It could be like this. It could be like this. It could be like this. But it is straight. This is straight line. Alright? So straight line is not bent. Then we have curved line. Curved line. So curved line will be bent just like this. Like this. Like this. All these one are curved lines. Alright? Then we also have another one that we want to look at is we also have what we call horizontal line. Horizontal line. Please take note of this. Horizontal line. Horizontal line is a line that is drawn from right to left. You understand? You move it from right to the left. So for example, you have a line like this horizontal line. It's a straight line, right? Horizontal line is also a straight line, but it is drawn from what? Right to the left, and you move from right to the left. While the other one is vertical line. Vertical line. You can see how all these things are linked together. If you understand how they are linked together, you'll be able to understand it very well. The next subsequent one. So vertical lines are the one that is drawn from up to down. up to down. This is what we call vertical line. Now, if you now have a vertical line and horizontal line meeting at a point, it's going to form what we call perpendicular line. Perpendicular what? Line. Perpendicular what? Line. I hope I'm making sense. That is, when you have a horizontal line, you have a horizontal line like this, and you now have another vertical line like this. They are meeting at this point here. So at this point here, this line is, the horizontal line is perpendicular to the vertical line. The vertical line rather is perpendicular to what? To the horizontal line. So that means it's formed an angle of 90 degrees at the where they are meeting. They are both meeting at this point. And if you see any line that formed, if you have two lines that meet and formed angle 90 degrees, that line, the two lines are what? Perpendicular what? Lines. For example, you can have it this way. This is a line, all right? And you can have another line that goes like this. And at this point here, these two lines formed an angle 90 degrees. So this line and this line are perpendicular. I hope I'm making sense. So that is that on that one. Then we also have parallel lines. So that is the next one we want to look at. Parallel lines. Let me clean here. Parallel lines. That would be number 8, right? So number 8 here, we have parallel lines. Parallel lines. So lines, rather. This one is also lines. So please take note. So parallel lines. When you talk about parallel lines, they are a set of lines. They are lines. It could be 2 lines, it could be 3 lines. So when you have lines that are parallel, they can never meet. When 2 or more lines are parallel, they are lines that can never meet. That's different from intersecting lines, which we are going to look at. So parallel lines are lines, no matter how you draw the lines, if you continue to extend the line till eternity, they will never meet. That's what we refer to as parallel lines. And how do we know that 2 lines or 2 or 3 lines are parallel? So there's something we use to denote that, is when you have an arrow on it. This arrow shows that these 2 lines are parallel. So if I should draw another lines here like this, I can have it this way. I just put 2 arrows there. So it does to differentiate between the 2. So this one shows that this line, if this is AB, the line is AB here, and this one is CD. So we will say that AB is parallel to what? To CD. These 2 lines, base lines, shows the symbol for parallel lines. So AB is parallel to CD. So line AB is parallel to lines what? CD. You can say I put this line here. Sometimes it could be written this form, AB in this form. This means it shows line is parallel to what? Line CD. Are you with me? So parallel to line what? Line CD. And also this, if this is X and this is Y, and this is P and this is Q. So we also say that XY is parallel to what? To what? PQ. So I hope I'm making sense. So that is all referred to as parallel lines. The 2 lines that can never meet. But this line PQ and line AB are not parallel because we can see that they are meeting at this point. So that is intersecting line. So that will be the next one. Intersecting what? Lines. Intersecting lines. So that is the next one. Intersecting lines. Lines. So when you have line and they're intersecting, so these 2 lines are intersecting. All right. So we are still going to look at some theorems here. That we have so many theorems that we can look at. We have parallel lines and transversal. We're going to look at transversal. So when we talk about that one, don't let me introduce that one here. The last one we're going to look at under lines is the last one is segments. Segment of a line. So segment of a line, we have different kinds of segments. The segment of a circle, you understand? So we have that one as well. But here we're referring to segment of a line. So segment of a line is just a portion of a line. For example, we have this. We have this line here, we have this line. This is a line here, all right? So this line AB. Now, how to bring out a portion from this line? So I can just say, okay, from here to here is CD. So this line here, this CD here, is a segment of this line. That is a part. Part is a portion. Part or a portion of a line is what we refer to as a segment. Don't forget, in recap, we've looked at line, right? Points. Points will lead to what? Point shows the position of an object in space. Then line, set of points. Set of points will form a line. Then other lines we then have, I explained horizontal line, the one that will move from right to the left. This is horizontal. While vertical is one that will move from up to down. So then we also talk about perpendicular line. That is when vertical line and horizontal line intersect. When they intersect, so this at the point of intersection, it will form angle 90 degrees. So that is another one. We also look at parallel lines, that is lines that can never meet. We look at intersecting lines, and we also look at segments. So in the next one, we want to look at angles. So now go back to angles, because understanding of lines will make you to understand what angles, right? So angles. So when we talk about angles, I said understanding of lines will make you to understand angles. So when you have two lines meeting at a point, so that phase. So we have, for example, you have this a line, it's a straight line. You have another straight line. These two lines are meeting at this point. These two lines are meeting at this point. So that means the distance between the lines, the distance between the lines is all referred to as angle. So this is an angle. So if you want to define angle now, you say space or the distance between two lines meeting at a point is all referred to as an angle. All right. So before we move on, we need to look at types of angles. We have different types of angles. So the first one, we're going to look at types of angles too. Types of angles. So the first one is acute angle. Acute what? Angle. So acute angle is an angle that is less than 90 degrees. Angle that is less than what? 90 degrees. Angle that is what? That is less than 90 degrees. That is less than 90 degrees. Less than 90 degrees. So any angle that you see that is less than 90 degrees from 0 to 89 or 89.9 is all referred to as what? Acute angle. Then we also have two. The second one is obtuse angle. Obtuse angle. So obtuse angle is an angle between that is greater than 90 degrees but less than 180 degrees. So angles greater than 90 degrees but what? But less than 180 degrees. So any angle that is greater than 90 degrees but less than 180 degrees. For example, you have 128 degrees. So you can see 128 degrees is more than 90 degrees, but it's less than 180 degrees. If I should put like 73 degrees here, this is less than 90 degrees, right? So, and the next one is reflex angle. Reflex angle is very important as well. So reflex angles are angles that are greater than, you can see the trend where it's going. The reflex angle are angles that are greater than 180 degrees but less than 360 degrees. So angles greater than 180 degrees but less than 360 degrees. So for example, if I have 183 degrees, 249 degrees, right? 359 degrees. All these angles are reflex angle. Then the fourth one, which will be very, very important for us to look at, is right angle. Do I have mentioned it before? Right angle. So right angle is equal to what? 90 degrees. Any angle that is equal to 90 degrees is referred to as what? Right angle. I hope that is very clear. So and then so that is that on types of angles. Then we are now going to move into clock. So difference between the clock, hour hand, and the minute hand. We want to look at that. But before we look at that, we need to look at what we call revolution. Revolution. Revolution in mathematics is not the revolution you know each night. So revolution is talking about when you turn when minutes or when minutes hand or hour hand move starts from the 12. We have 3 here, we have 9 here, we have 6 here. So we have a circle like this, a clock, right? So in between this we have 1, we have 2, we have 4, we have 5, we have 7, we have 8, 10, we have 11. So at the center here, this is the hour hand, right? And we can have the minutes hand like this. So the shorter hand, this one here, is the minutes hour hand, and this is the minutes hand. The longer one is the minutes hand. So what to look at? So with this minutes hand should start from this 12 and moves back to 12. It has taken a revolution. That is, for example, now if you are driving, you are for example, you have a tire, because all these ones we're still going to look at them, but now we're looking at plane shapes. And we're looking at the application of plane shapes. You know, a tire, bicycle tire. You have a bicycle, all right, and then this is the bicycle. This is the rim, right? Now, this rim, by the time this rim is starting from this place, it now turns, moves, and it comes back to this place. That means that this line has turned a revolution. You understand? Has turned what? A revolution. So a revolution is that when you moved around a complete circle, you moved around a complete circle. If this hand turns a revolution, that means it has moved around a complete circle. And a revolution mathematically is talking about 360 what? Degrees. So that is another type of angles that we're going to look at. That is a revolution is what? 360. Now we now have, is either you move clockwise or you move anti-clockwise. Mind you, if you look at this, can this the minutes and the hour hand always move clockwise. That is, when you say clockwise in the sense that you are moving the way the minutes and hour hands move on a clock. That is, turns like this, turns like this, turns like this, turns like this, turns like this. That is clockwise. Then we also have what we call anti-clockwise. Anti-clockwise. That is, anti means against. In English, anti means against. If I say anti-terrorist, against terrorist. Anti-clockwise, against clock. That is, you are moving in the reverse portion of the clock. So instead of it to move from left to the right, you are now moving from right to the left. That is against the clock, like this. I hope I'm making sense. You are moving this way. This is what refers to as anti-clockwise. I hope I'm making sense. So all these things are what we're going to be looking at. Now let's now look at the distance. We want to look at the degrees, and this is measured in degrees. Like I've explained it, this is measured in degrees. So let's say we have this clock again. All right. So we have this. We have 12 here. We have 3 here. We have 9 here and 6 here. So this is 4. This is 5. This is 7, 8, 10, and 11. So if this is 2 and this is 1, we have this here. This is the minute hand, and we have the hour hand on 4, directly on 4. Now the question can ask you, find the shortest, the smaller angle between the minutes and the hour hand. If you look at it, I said something on that angle. Please take note. This is very simple. I said an angle is the distance between two straight lines. This line and this line, they are meeting at this point. We have formed 2 angles. You ask me, how come? How do we have 2 angles? We have 2 angles here. So this is the first one. This is 1 year. Amount of turn. That is distance. Then we have another angle at the back here. So which one is bigger? This one is bigger, while this one is smaller. So it depends on what the question asks you to do. The question asks you to find the degree of the larger angle, right? Which we are referring to this. The smaller angle is the one inside. I hope I'm making sense. So for example, you want to find the degree of this angle here. How do we find that? So the first thing you need to do is the revolution is 360 degrees, right? Now, between how many space? We have 12. 1, 2, 3, 4, 5, 6, 7 to 12. Then how many do we have there? From here to here is 1, 2, 3, 4. That is 4. Out of the whole numbers we have there, 12. Then the whole degrees we have there, the total revolution is what? 360. Then multiply by 360 degrees. So 4 here 1, 4 here 3, 3 here 1, 3 here, and that is 12. So that means it's going to give us that's 120 degrees. That is 0 here. So that is the angle we have between the hour hand and the minute hand at 4 o'clock is what? 120 degrees. So the question can come another way. If I ask you to find so sometimes this clock will not be drawn for you. Just have this. Find the angle between the smaller angle. Let me put that way. The smaller angle. But when smaller is not there, so they are referring to smaller angle. The smaller angle between the minutes and the hour and at 4:15. 4:15. Sometimes we 4:45 to 10 minutes to 3 minutes to all those ones. How do you do that? It's very simple. Another way, before we come to this one, another way of doing this is we look at how many minutes do we have between this place and this place, because this is all this one are minutes. For 60 minutes we make what? This is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So we take how many minutes do we have there? 5, 10, 15, that's 20. So 20 out of 60 minutes multiplied by 360. That's another way of doing it. So 0 cancels 0. 2 here 1, 2 here 3. 3 here 1, 3 here 120. 120 degrees. This is still the same thing. But they can give you something that will involve for minutes. So what we're going to do is this. So 4:15. 4:15 you have this. So we have this 12. We have 3. We have 6. We have what? 9. So at 4:15 the minutes hands will be here. And this is 4. This is 5. So the hour hand will be here. You can see the difference. So how many minutes do we have between 3 and 4? We just have 5 minutes. So that will be 5 out of what? 60 minutes times what? 360. 0 cancels 0. 6 here 1, 6 here 1, 6. 6 and that's going to be for 30 degrees. Can you see that? Can you see that? It's very simple. Right? So that is that on this. So it can be small, bigger. If they ask you for the bigger one, so you just know that, okay, how many minutes we have there? That's going to be 55 minutes out of 60 minutes times what? 360 degrees. Or you just subtract this one from 360. You get what? 330 degrees. 0 cancels 0. 6 here 1, 6 here 6. So that is 55 times 6. This is 30, 33. That's 330. So just subtract this one from 360, you get the same. I hope this is very clear. So that is that. So how to calculate angles between the minutes and the hour hand. So the question can come in any form. You understand? So for your quiz, you should not be expected to be direct. But understanding of the main concept will let you understand it. By the time you see the question, just take your time to interpret the question before you solve it. Is that clear? Alright, before we proceed to the next subtopic, so let's look at these examples. So we have the first one. How many degrees do we have in 4 revolutions? 1/12 revolution. Don't forget that on the solution to this, I said a revolution is for 360 degrees. So 4 revolutions will then be what? So the 1A, 4 revolutions. Since a revolution is 360, that will be 4 multiplied by what? 360 degrees. So multiply this, and this gives us 0. 4 times 6 times 24. The 2. This is 12. That is 1440 degrees. That's 4 revolutions. How that is very clear. Then B is 1 over 12 revolutions. So that means 1 over 12 multiplied by 1 revolution is 360 degrees. So that is 12 here 1, 12 here 3. That is 30 degrees. How that is very clear. So that is that and that one. Then for number 2, how many revolutions in this and this? That is, how many 360 can we bring out from this? So that means that we're going to divide this by 360. That's what it means. So that means how many revolutions? That is A. So that will be 288 divided 2,808 divided by 360. So degrees. So 0 cancels 0. Alright? So 2 can go here, 18. Alright? 2 can go here, 144. Alright? 2 can see go, that is 9. 2 can go here, 7, 2. 9 here 1, 9 here 8. That is going to be 8 revolutions. How about with you? 8 revolutions. How that is very clear. 8 revolutions. So the third B aspect of it. So 45 degrees. That's 745 degrees divided by 360. Divided by 360 degrees. Alright. So 5 can go. 5 here is 9. 5 can go here. That is 7. And that's 72. 9 here 1. 9 here is 8. That is what? 1 over 8. 1 over 8 revolutions. Revolution rather. 1 over 8 revolution. It is less than 1. 1 over 8 revolution. I hope this is very clear. So the third one, how many revolutions does R and of a clock turn between 4 p.m. and 7 p.m.? So the first thing you need to calculate here is how many hours do we have between 4 and 5? So from 4 to 5, that is 1, right? 5 to 6, that is 2. 6 to 7, that is 3. That is 3 hours. So and in 1 hour is equal to 360 degrees. That's 1 revolution. 1 hour is 1 revolution. 1 revolution, which is equal to what? 360 degrees. So between 4 p.m. and 7 p.m., we have 3 hours. That's going to give us 3, because 1 hour is equal to 1 revolution. That's going to be 3 revolutions. I hope that is very clear. So that is that on this one. So we can then move to relationship between minutes, hour, and degrees. So this is where we're going to stop in this video. In the next video, we're going to continue from relationship between degrees, hours, and minutes, and see how we can convert from degrees to hours to minutes, seconds, and so on and so forth. Then we also look at the arithmetic operations between the two of them. So this is where we're going to stop. So if you are new to this channel, don't forget to subscribe and make sure you turn on your notification bell. So anytime I release video like this, you'll be able to have access to it and benefit from it on time. So going to meet you in the next class. Bye for now.